Okay, good morning to all. So in the last class, okay, we discussed about the one of the important technique in data structure called as caching, and we discussed about something called as the definition of caching and why the caching is needed, and what are the advantages of caching, and what are the various applications of caching, and also we discussed about the different types of caching. Okay, so I will go through the quick reference of the concept. Okay, so what is the concept of caching is nothing but let us consider a computer memory in real time. If you want to place any data in your computer memory, you know there are some n number of blocks in the computer memory. So let us consider if you are going to place any data in your computer memory in a particular block, you consider the block is already filled, then you want to place the data in the same location where the box is filled. Okay, so at this stage it technique which used to reduce the concept called as collision, and it paves the way for the solution to place your data in the particular location of a memory. Okay, so it is the definition of the caching. Okay, so it is nothing but a technique which searches the particular place for fixing or placing the element without any collisions. Okay, so that is the definition of caching. Okay, so for the caching, for solving the caching, we are having four techniques. Okay, four methods. So one is called as division method, another is called as truncation method, then another one is called as mid square method, another one is called as folding method. Okay, so among the four methods we saw about the concept called as division method. Okay, so it is also called as the modulo method. Okay, division method or modulo method. Okay, so in our topic we discussed about the concept of division method of caching. Okay, then followed by, so there are some various advantages of caching. So if you're going for caching concept, it paves the way for better searching and quick allocation of elements without any collisions. Okay, and the search time of the particular element and placing time of the particular element will take the less time for the process. Okay, so under the caching we are having three types. Okay, so one is called as linear probing, another is called as quadratic probing, another is called as separate chaining. Okay, so in the linear probing what we discussed is, let us you are going to use the formula that is nothing but h of k is equal to key mod n. Okay, so you are having each and every element, so that is to be taken as a key. So each and every element is modulo with the help of the value n. So the n is nothing but the table size. Okay, so in some of the question papers you are getting the table size in the question paper itself, or you have to count the number of elements you are having, and you have to create the table size up to the next prime number of the number of elements in which you are having. Okay, so your index value of the table might be the next prime number of the elements count in which they are giving. Okay, so likewise if you are solving that one, So you are going to place your elements in a linear probing. If any collision is occur, you got to place the element in the next location where the empty location is there. Okay. So this kind of thing is the cyclic process which is going in the concept of linear probing. Okay. Then followed by we discussed about the concept of quadratic probing. So in the quadratic probing, I gave one that is the corollary, the statement which is used to solve the collision occurrence problems in the that is quadratic probing. Okay. So initially, if you are getting any collision, that is to be taken as I. Then if the collision is occurs, you got to move for the next place, that is I plus 1 square. Then again the collision is occur for the next time, you got to go for I plus 2 square. Then again the collision is occurs when you also go for I plus 3 square. It is going up to n squares, that is I plus n square operations. Okay, this is the concept of quadratic probing. Then last one is nothing but separate chaining. So it is also one of the collision resolution technique in hashing, which mainly uses the concept of linked list. Okay. For example, in your table, if you are getting any collision, you got to place the same two datas in the particular location with the help of a link pointer. Okay. So that is the advantage of this separate chaining. Okay. So these are the topics we discussed in the last class. Okay. So I already told in the unit, the very important topic is the hashing concepts, which is definitely important for your examination point of view. Okay. And this hash method of operation is used for n number of applications in real time. And this kind of operation is mainly used for providing the security for transferring the data from one place to another without any data loss. Okay. I hope you are going to study in further in the forthcoming semesters. There is a subject called as cryptography and network security. So in this subject, you are having the application of hashing for generating a keys based on the operation of hashing. Okay, ma. I hope all of you understood the quick review of hashing. Is there any doubt in hashing? Can we go for the new topic?
Yes, sir.
Okay, fine, ma. Okay. Then in this class, okay, we are going to see a new topic which is called as searching operations in data structures. Okay, search operations in data structures. Okay. So whether the screen is visible to all, whether the screen is visible to all, ma? Can anyone reply? Screen is visible. Okay. So now we are going to see one of the new topic, okay, which comes under the concept of data structures. Okay. So that is nothing but a searching algorithms. Okay. Searching algorithms. Okay. So what is the general meaning for searching? So what is searching? What is the meaning for searching?
Finding something or some element.
Okay, fine. Okay. It is used to finding something or some elements which is present in a particular place. Okay. So that is called as a searching operation. Okay. So let us say, for example, let us consider you see in real time. Okay. Let us consider there are some 60%, 60 people in your class. Okay. So I want to search a particular boy or girl in your class. Okay. So let us say, for example, I am taking the boy name as Adis in your class. Okay. So how can I search for the particular boy Adis? So there are 60 people in your class. So what are different way of searching? எப்படியெல்லாம் பாசிபிலிட்டி இருக்கு சொல்லுங்க பார்க்கலாம். எப்படியெல்லாம் நான் அந்த பையனை கண்டுபிடிக்க முடியும்? So what are the possible ways? I know only the thing, a key which is I'm having is Adis. So what are the different ways of searching the particular boy Adis? Can anyone tell? I'm having only the boy name and I'm entering into your class. So how can I search the particular boy named as Adis? So what are the possible ways? So what are the possible ways?
By calling his name.
Okay. Okay, very good. Okay. So there are some different ways. Okay. So one of the way is by calling his name. Okay. So whenever I enter into your class, so I'm calling the person called as Adis. Okay. Adis come out. Okay. Or Adis stand up like that. Okay. So likewise, we are having some different approaches, different perceptions. Okay. So based on the user view, for example, my perception is, my view is, I am going to enter into your class. I am calling Adis, please stand up. Okay. So if I am saying like that means that boy Adis is standing in the class, then I am identifying the particular boy Adis is identified. Okay, in your class. Okay. So likewise, this is some general searching. Okay, this is some general searching operations. Okay. So let us consider we are talking technically, okay, based on the computer terms. Okay, so I am going to enter into your class. How the computer searching is like this. Okay, so I am going to enter into your class. So I am asking, for example, the boy name is Adis, Adish. Okay, so I am entering into your class. I am saying, okay, the persons who is having a letter starting with A. So all of you please stand up. Okay, if I am saying like that, okay, so there are some persons who is having the name which starts from A, or all are standing. Okay, so can you tell approximately how many members are there in your class with the letter, starting letter of their name as A? Approximately. Okay, so let us say you take it as 10. Okay, let us say you take it as 10. Okay, so let us consider you are having 10 people with their name, the first letter of their name starting with A. Okay, so if I am saying like this, so all the 10 people are standing in your class. Okay, then so now I am getting confused. Okay, so how many members are there in your class? things about searching operations. I hope all of you understood about basic things about searching operations. All of you are following. Okay. So followed by the definition. Okay. So there is some definition for searching. It is nothing but you are going to find out a particular element in a particular place with the use of keyword or some number of elements or key elements or something called as patterns. Okay. So that is the basic definition or the objective of hashing. Okay. So see here, in this searching operation we are having, let us consider given a collection and an element to find. Okay, let us say there are some collection of elements. So among the collection of elements, the key is given to find out the particular element in a given list. Okay, so we are having two possible ways: whether the list is found in the particular place, it is given as the message is printed as print found or not found. Okay, or if you are going to search a particular element with a key, it returns a particular position of the element which is already available in the place. It could only search or it could only identify or find the elements in the list. Okay, then as I told earlier, we are having two types of searching in data structures. One is called as linear search, another one is called as binary search. Okay, so before going to see the topic deeply, okay, so I'm having the some examples. Okay, so are all of you following? Okay, so என்ன சார் ஹேங் ஆயிட்டே இருக்கு சார் ஹாட்ஸ்பாட் தான் போட்டுருக்கு சார் சரி சார் okay, so there are some, I already told we are having two types of hashing operations. Okay, one is searching operations, one is called as linear search, another one is called as binary search. Okay, so let us say we will go with some example. I hope all of you know about the old radio system, that means nothing but tape recorder. Okay, I hope all of you know about the tape recorder which is used in olden days for hearing the musics. Sir. You know about the tape recorder. Okay, you are used in the olden days. Recorder, you consider there is something called as cassette. Okay, you are inserting something called as cassette னு ஒண்ணு உள்ள போடுவாங்க, பாத்திருக்கீங்களா cassette. Okay, so அந்த cassetteல பாத்தீங்கன்னா 50 songs. Okay, ஒரு 50 song இருக்குன்னு கன்சிடர் பண்ணீங்க. Okay, you are considering there are some 50 songs in your cassette. Okay, so let us consider I want to play the song number 27. Tape recorder consider பண்ணிக்கங்க. அந்த tape recorderல பாத்தீங்கன்னா we are going to use one thing called as cassette. Cassette ஒன்று யூஸ் பண்ணுவோம். அந்த கேசட்டுங்கிற எப்படின்னு பார்த்தீங்கன்னா there is something called as magnetic strip. Okay, magnetic label மாதிரி இருக்கும். அதுல magnetic strip இருக்கும். அதுல வந்து நம்ம சாங்ஸ் வந்து ரைட் பண்ணியிருப்பாங்க. ஓகேங்களா? ஸோ அது எப்படி ரீட் ஆகும்னா நம்ம டேப் ரெக்கார்டில் பார்த்தீங்கன்னா ஹெட்னு ஒன்று இருக்கும். அந்த ஹெட் வந்து அது மாதிரி டச் பண்ணுறப்ப அந்த மேக்னெட்டிக் field, okay, magnetic field produce ஆகி it will display the output as in the format of songs by the help of electromagnetic waves. ஓகேங்களா? ஸோ அந்த ப்ராசஸ். ஓகே, ஸோ அதில் பார்த்தீங்கன்னா அந்த கேசட்ல பார்த்தீங்கன்னா யூ கன்சிடர் தேர் ஆர் சம் 50 சாங்ஸ், 50 சாங் இருக்குன்னு கன்சிடர் பண்ணிக்கங்க. ஓகேங்களா? அந்த 50 சாங்ல நான் வந்து என்ன பண்ண போறேன், 27th சாங் ப்ளே பண்ணணும்னு நினைக்கிறேன். ஓகேங்களா? 27th சாங் ப்ளே பண்ணணும்னு நினைக்கிறேன். ஓகே, ஸோ வாட் ஆர் தி பாசிபிள் வேஸ், எப்படி ப்ளே பண்ண முடியும்? ஓகே, ஸோ அந்த பழைய டேப் ரெக்கார்டில் பார்த்தீங்கன்னா ஓகே there are some only two options. Okay, there is no possibility of directly selecting the particular song. அதாவது சாங் நம்பர் 27 ப்ளே பண்ணு சொல்லி டைரக்டா வந்து ப்ளே பண்ண முடியாது. ஓகேங்களா? ஸோ இந்த டேப் ரெக்கார்டர் we are having the option called as forward operation and backward operation. ஓகே, அதில் பார்த்தீங்கன்னா ரிவர்ஸ் ஒன்று இருக்கும், பேக்வேர்ட் ஒன்று இருக்கும். ரிவர்ஸ் ஒன்று இருக்கும், ஃபார்வர்ட் ஒன்று இருக்கும். ஓகேங்களா? ஸோ ரிவர்ஸ்னு கொடுத்தீங்கன்னா உங்களுடைய சாங் ஃபார் எக்ஸாம்பிள் ஒரு 50th சாங் இருக்கிறீங்கன்னா 27 சாங் வர வரை நீங்க என்ன பண்ணணும், ரிவைஸ் பண்ணணும். ஓகே, ஆர் எல்ஸ் if you are having this, if you are in the song number 25, okay, for moving to the song number 27 you have to go with forward operation. Okay, so this kind of searching is called as linear searching. ஓகேங்களா? ஒரு பெஸ்ட் எக்ஸாம்பிள் என்னன்னு பாத்தீங்கன்னா old tape recorders, the cassettes which are used in the old tape recorders. Okay, that is a very good example for linear search. The next one is nothing but binary search, or sometimes called as random search. The example is nothing but the compact discs. Okay, compact discs or CD. Okay, so CD இருக்குல்லையா, compact disc. Okay, so in the CD you are going to write your songs. Okay, so whenever it is inserted into the CD player, automatic CD player, you are having a remote control, or the player might be having some buttons for selecting a particular songs. Okay, so for example you consider the same thing. In your CD you are having 50 songs, then among the 50 songs I am going to hear now the 27th song. Okay, so I am taking my remote control and I am pressing the number 27, then directly the song number 27 is playing. Okay, so this is nothing but a direct search, okay, or something called as random search, where the user can directly involved in the operation of selecting a particular songs. Okay, so based on this example, now you getting into the operation of linear search and binary search. Okay, then now you see the linear search. Okay, so it is the definition of linear search where the searching operations may be taken place in the format of one by one. Okay, so let us consider in your computer memory there is a memory location. Now you consider the memory location as in the format of arrays. Let us consider there are some 7 memory locations. So you are placing some elements in the 7 memory locations. Let us consider among the 7 elements you are placing one element called as A. Let us say the A is located at the index value of 6. It means the last position in the array. Okay, so how we are going to search this one? So you have to starting from the first index value 0, then you got to move to, if it is find, okay, then the process stopped. Okay, then you are going to check for the next location where the element is found, then the process stopped. If not, again it is incremented to the next position. Then you got to check whether the element is found. Okay, then you got to stop the process, or again the loop is incremented to the next position. Okay, so now you are in the 4th position. Okay, but our element is in the position of 6. So likewise you are going up to 5th position. Okay, so from the 5th position, if you are checking for a particular element, if it is not found, again you are incrementing to the 6th position. So in the 6th position, your particular element what you are searching is found. You have to write that the element is found. Okay, print the element is found. Now the process is stopped. Okay, you are achieved the target. If you are finding the target means here the process is stopped. Okay, so this kind of searching is nothing but a linear search. Okay, this kind of searching is nothing but a linear search. Okay, so it is the searching which provides the effective way of finding a element, but it will take time. Okay, so as I told earlier, it will take time. Okay, because you have to check each and every element. Okay, you have to check each and every element from the initial stage up to where the element is to be found. Okay, so it is the basic concept of the linear search operation. Okay, so now we are going to see one algorithm, okay, or coding C program. Okay, how the searching operation is taken place in the real time scenario. Okay, oh, okay, so likewise the linear search operation is going on. Okay, see here the definition: a search traverses the collection. Okay, அதாவது linear search என்னன்னா, அதாவது ஒரு எலமெண்ட்டை சர்ச் பண்றீங்க, ஃபர்ஸ்ட்ல இருந்து சர்ச் பண்றீங்க, அந்த எலமெண்ட் ஃபவுண்ட் அப்படின்னா அதுக்கு பின்னாடி நம்ம அந்த எலமெண்ட்டை சர்ச் பண்ண தேவையில்லை, அதோட ஸ்டாப் ஆயிடும். ஓகே, அதே கொடுத்துருக்காங்க. A search traverses the collection until the desired element is found or the collection element is exhausted. ஓகேங்களா? ஸோ சிம்பிளா கொடுத்துருக்காங்க பாருங்க, லாஸ்ட் லைன்ல ஈஸியா புரியுற மாதிரி. அதாவது I can stop looking when I know the element cannot be in the collection. ஒன்று, நீங்க சர்ச் பண்ண எலமெண்ட் அந்த லிஸ்ட்டுக்குள்ள இல்லைன்னா நீங்க சர்ச் பண்ண வெளியே வந்துடலாம். இல்லைன்னா நீங்க கேட்குற எலமெண்ட் இருந்துச்சுன்னா அதோட ப்ராசஸ் ஸ்டாப் பண்ணிட்டு வெளியே வந்துடலாம். ஓகேங்களா? Then see the routine. Okay, see the routine for unordered search. Okay, nothing but a linear iterative search. Okay, you have to first fix the number of elements. Okay, that means n. It means அதாவது first வந்து you have to fix the size of the array. For example, you have to fix the size of the array. In the size of the array, you have to give the indices for each and every element in the array. Okay, so for searching a particular element, for example, as I told earlier, my element is 7 means it is my target. Okay, it is my target. Okay, so let us consider the target is nothing but I. So you are taking the target with, you are comparing the target or taking the target with each and every element. Okay, so greater than the maximum limit of the array, that is not greater than the maximum limit of the array. If the maximum limit is founded, you have to exhaust or exit from the array because the searching element could not found in the array. Okay, or if the targeted element, that is I is equal to 7, if it is found in the array, you have to stop your process and come outside of the loop. Okay, that is the nothing but an coding which is shown in the screen. Okay, ma? So this is the step. Okay, so listen, all of you see the screen. This is very, very important. I am having one array. The array name is nothing but my array. Okay, எங்கிட்ட ஒரு array இருக்கு. array என்னன்னா nothing but a memory location. எங்கிட்ட ஒரு memory location இருக்கு. So அதோட நேம் என்ன பாத்தீங்கன்னா my array. Okay, so in my array I am having 6 elements. So the elements are 7, 12, 5, 22, 13 and 32. So நான் என்ன பண்ண போறேன், இப்போ என்னோட மெமரி லொகேஷன்ல நான் ஒரு எலிமெண்ட் சர்ச் பண்ண போறேன், இருக்கா இல்லையான்னு செக் பண்ண போறேன். ஓகேங்களா? let us say the target is 13. Let us say the target is 13. So for that, in linear search operation, I am going in a sequential order. அதாவது என்னோட அரேல ஃபர்ஸ்ட் லொகேஷனை செக் பண்றேன். 13 வந்து டார்கெட், அது வந்து 7 ஓட மேட்ச் ஆகுதான்னு பார்க்குறேன். மேட்ச் ஆகுதா இல்லையா? மேட்ச் ஆகல, இட் இஸ் நோ. Then I will increment the position 1 of the array to the next position, that is the second position of the array. It is move to the next location, that is 12. இப்போ என்னோட டார்கெட் 13 வந்து 12 ஓட மேட்ச் ஆகுதான்னு பாருங்க. It is not matched. Again I am incrementing my array. Okay. The next, you are comparing your target with the next element in the array. Then you check whether it is mapped with the target. No. Then again you are going to increment the array. It is not matched. Then now you have to check whether the target is equal to the element you are searching. Okay, so now it is matched because the target is 13, our identifier element is 13. Okay, it is available in the location of 5. So if the element is found, okay, then our process is stopped and printing the elements. Okay, ma? இப்போ நம்ம 13 பார்க்குறோம். 13க்கு பதிலாக ஃபார் எக்ஸாம்பிள் யூ சே த டார்கெட் இஸ் 35. இட் மீன்ஸ் அதுவும் 13க்கு பதிலாக 35 இருந்துச்சுன்னா என்ன ஆகும்? இங்கே சர்ச் பண்ணும், இட் இஸ் நாட் ஃபவுண்ட். நெக்ஸ்ட் 32 செக் பண்ணும், இட் இஸ் நாட் ஃபவுண்ட். என்ன ஆகும்னா டார்கெட் நாட் ஃபவுண்ட். ஓகே, அப்படின்னு வரும். ஓகே, பட் இங்கே நமக்கு பார்த்தீங்கன்னா the 13 is founded. So here we are found in the targeted data. Okay, ma? So we identified the data which is what we targeted. Okay. So this kind of searching is nothing but linear searching. Okay. Then there are some, if you are going for any kind of algorithm, okay, and before going to see this, understand my points. So if you are going to work with any kind of algorithms, okay, you got to taken care of 3 things. One is called as, there are 3 kinds of algorithm. One is called as best case algorithm. Another one is called as worst case algorithm. Another one is called as average case algorithm. Okay, so whenever you are writing an algorithm or you are using an algorithm for solving a particular problem, you have to target. Okay, you have to target. Okay, you have to target the 3 things. Okay, one is the algorithm provides the best solution or the worst solution or average solution to the particular problem. Okay, see the which they are classified into 3 things. Okay, best case algorithm, worst case algorithm and average case algorithms. Okay, so among these 3 things you got to choose only the best case algorithms. Sometimes if not possible, you have to take it as average case algorithms. Okay, you have to avoid the usage of worst case algorithms. Okay, so like we see here in this screen, we are having something called as best case algorithm. A best case algorithm enna, the same problem thukku first we are seeing the target as a first location. First location la ungalde first item irukanu check பண்றீங்க இல்ல, whether the target is 7. Okay, அதாவது நீ செக் பண்ற எலிமெண்ட் வந்து ஃபர்ஸ்ட் எலிமெண்டா இருந்துச்சு அப்படின்னா it is nothing but a best case. Okay, so அதாவது என்னன்னா பெஸ்ட் கேஸ் மீன்ஸ், அதாவது நம்ம ஒரு அல்காரிதம் எழுதுறப்ப நம்ம எலிமெண்ட் வந்து ஃபர்ஸ்ட் எலிமெண்டா இருக்குது, நம்ம டார்கெட் பண்ணக்கூடிய எலிமெண்ட் ஃபர்ஸ்ட் எலிமெண்டா இருந்துச்சு அப்படின்னா குயிக்கா நம்ம கண்டுபிடிச்சிட்டோம், ஃபர்ஸ்ட் ஸ்டேஜ்லயே கிடைச்சிருச்சு அப்படின்னா இட் இஸ் கால்ட் அஸ் பெஸ்ட் கேஸ் அல்காரிதம். ஓகே, ஆர் இட் கோஸ் n நம்பர் ஆஃப் ஸ்டெப்ஸ். ஃபார் எக்ஸாம்பிள் 7 இங்க இருக்கு, நெக்ஸ்ட் இது பாருங்க 32 கண்டுபிடிக்கணும்னா ஃபர்ஸ்ட் 7 பாக்குறோம் இல்ல, மறுபடியும் லூப் இங்கே வருது 12 பாக்குறோம் இல்ல, மறுபடியும் லூப் இங்கே வருது 5 பாக்குறோம் இல்ல, நெக்ஸ்ட் 22 லூப் இங்கே வருது இங்கே பாக்குறோம் இல்ல, நெக்ஸ்ட் வந்து 13 போகுது இங்கேயும் இல்ல, லாஸ்ட் அதை என்ன பண்ணுது 32 வருது. ஓகேங்களா, ஸோ இது என்ன பண்ணுது, there are some limitations. Okay, it shows there are some limitations in your linear search algorithms. என்னன்னா it will take time. Okay, இப்படி நம்ம சர்ச் பண்றோம் என்ன ஆகுது அப்படின்னா it will take time. The time which is used to searching a element is more. Okay. So whenever we are talking about the concept of algorithm scenario, you should always use the algorithm which takes the less time. Okay, ma? So based on that concept, okay, so this linear search algorithm could not provide the best solution for all kind of problems. ஓகேங்களா? ஸோ என்ன சொல்றாங்க அப்படின்னா, ஸோ உங்க லீனியர் சர்ச் அல்காரிதம் வந்து எல்லா ப்ராப்ளத்துக்கும் வந்து கரெக்டான சொல்யூஷனை கொடுக்காது. அது மீன் இட் குட் நாட் பி டேக்கன் ஃபார் ஆல் ப்ராப்ளம்ஸ் because it takes more number of time. Okay, so this is the some of the limitation, okay, of the linear search algorithm. Then next, so இது எப்படி வந்து நம்ம reduce பண்றது? Okay, so how to give the solution for this algorithm? Then we are having something called as binary search algorithm. Okay, binary search algorithm. So simple சொல்றேன், புரிஞ்சுங்க. So binary search means, okay, so let us see in the screen, if I am looking for the value 42 or any value, okay, initially we don't know what is the value which we are searching. அதாவது you have to divide, okay, you have to divide your array into some n parts. You have to divide your array into n parts. It may be you have to divide a middle element, you keep a middle element, and you have to divide the remaining elements like that left side element or right side element, or you have to divide it at an intermediate thing, or you divide it as a first thing, or divide it as a last thing. Okay. So என்ன பண்ண போறீங்க? See the example. Here I am looking for the value 42. Okay. So என்ன பண்ணிருக்காங்க? It is divided into like this 3 ways. So middle element is 59. Then the remaining elements are here left side. The remaining elements are in the right side. So here I am searching whether the 59 is there, whether this 42 is coming after 59 or before 59. So if I identified that thing, I couldn't go for the searching operation after 59, 76, 81, 84, 99 up to all. Okay, ma? So எனக்கு என்ன அட்வான்டேஜ் அப்படின்னா, இதுக்கப்புறம் நான் ஃபர்தரா வந்து இந்த பார்ட்டுக்கு வந்து நான் என்ன பண்ண மாட்டேன், சர்ச்சிங் ஆபரேஷனுக்கு போக மாட்டேன். அதனால என்ன அட்வான்டேஜ் சொல்றாங்கன்னா, ஸோ டைம் வந்து ரொம்ப ரெடியூஸ் ஆகுதுன்னு சொல்றாங்க. புரிஞ்சுதாமா? ஸ்ப்ளிட் பண்ணி ஒர்க், அதாவது டேபிள ஸ்ப்ளிட் பண்ணி டேட்டாவை செப்பரேட் பண்ணிட்டு எந்த சோர்ஸ்குள்ள வருதுங்கிறத மட்டும் நம்ம செக் பண்ணி பார்த்தோம்னா ஈஸியா வந்து நம்ம டேட்டா ஐடென்டிஃபை பண்ண முடியும் அப்படிங்கிறாங்க பைனரி சர்ச்ல. ஓகேங்களா? see here. ஸோ இந்த ரெட் கலர் மார்க் பண்ணிருக்கு இல்லையா, இந்த பக்கம் நம்ம போகவே தேவையில்லை. ஏன் அப்படின்னா நம்மளுடைய எலமெண்ட் வந்து இந்த ஃபர்ஸ்ட் இதுக்குள்ளேயே வந்துடும். சரிங்களா? ஃபர்ஸ்ட் அரே பாக்ஸ்குள்ளேயே வந்துடுது. ஆனால் ஃபர்தரா பின்னாடி வந்து நம்ம எந்த ஆபரேஷன் பண்ண தேவையில்லை அப்படிங்கிறாங்க. ஓகே, ஸோ இட் இஸ் ஒன் ஆஃப் தி அட்வான்டேஜ் ஆஃப் binary search algorithm. Okay, ma? So I hope all of you understood. Okay, so what's the concept of binary search algorithm? Okay, see here also we are no work in the part of 1, 7 or 9 like that. Okay, so we are having only the work in this box only. So we got to directly concentrate on that box and we are finding a solution among this particular box. சொல்றது புரிஞ்சுதாமா? So this is the concept, okay, of the binary search algorithm. You are dividing your given array into some different split types and you find the middle element, you keep the middle element as a key and you have to check for a particular element if it is to be arranged in the left side or right side like that. If it is arranged in the left side or right side, you have to search, you got to do the operation only if it is available in the left side, means you got to do only the left side operations. You got to leave the right side array values. If it is available in the right side, means you got to check only the right side operations. You don't go after the left side array values like that. Okay, it reduces the time. Okay, so these are some of the operations which is coming under the concept of binary search. Okay, so while free, I am sharing this PPT in your Olympus portal. So while free, you have to go through and you have to read and learn the concept of searching operations very well. Okay, because it is very, very important based on your placements, and it is very important for your further higher studies. Okay, ma? The searching concept is very, very important. Okay. So I hope all of you understood the difference between the linear search and binary search and how it is working, and you understood some of the real-time examples also. I hope it will provide you knowledge about the concept of searching algorithms in data structures. Okay, so I hope all of you understood. Can anyone summarize what we discussed in this class? Can anyone summarize what we discussed in this class? Okay, can anyone summarize?
So we saw about just a small recap of what is hashing, and in this class we saw about search operations in data structure and the algorithm of that, and we saw what is searching, like their outputs, found, not found, and written value, and types of searching such as linear search, binary search, and about linear search and its algorithm. Linear search is effective but requires more time, and algorithms such as best case, worst case, and average case. And we saw about binary search analysis, and also we saw some examples of searching.
Okay, very good, ma. Okay, so it is very, very important topic. Okay, so most of the placement questions are comes from the concept of linear search and binary search like that. Okay, in the course of data structures. Okay, then for your examination purpose also it is very important. Okay, so they're asking what is searching and what are the different types of searching, and explain it with example like that. Okay, so you got to quote your own example and you have to write your answers. Okay, and you know very well about this thing. You can use if you are taking any kind of algorithm. For any algorithm we are having three kind of cases. One is best case, worst case, and average case. Okay, so if you are going deeply about the algorithm analysis, we are having something called as mathematical notations to represent the best case, worst case, and the average case like that. Okay, so we will discuss about that things in the next class. Okay, ma. So I hope all of you understood. Okay, so thank you all. Have a good day. Thank you.
Thank you, sir.
Okay.